Hello everybody, welcome to my academy and civil engineers. Today in this session we will discuss on two major topics which are intersection and resection, which fall under the topic orientation, and these topics are from surveying second. So let's get started. So let's first know about intersection. The process of finding the coordinates of a known station by placing the instrument at two known stations and targeting them to the unknown point is called intersection. So after reading this statement, we come to know about that here in this method there are two known points and we have to find one unknown points. For that, what we will do targeting the station from these two known points by placing the instrument on those known stations. So let the two known points be A and B. Here in this case the known points are A and B, whose coordinates are NA, EA and NB, EB respectively. So what we will do first, we will find the length between A and B because we are known the coordinates of A and B. So we simply use the distance formula root under NB minus NA whole square plus EB minus EA whole square. Now we can also find the bearing of AB because we are known here the coordinates of A and B, and the formula of the bearing is tan inverse under bracket easting by northing. So easting of B minus easting of A by northing of B minus northing of A. Here angles measured at A and B be alpha and beta, which is as shown in the figure also. Then we can find the value of gamma. How? As it is triangle, yes, when we target the point from two known points, then it will form triangle. So we can use here the property of triangle, that is gamma equals to 180 degree minus alpha plus beta. Now after finding the internal angle by instrument, we can find now bearing of AC. We can find bearing of AC, this bearing of AC line by, as we know bearing of AB, yes, bearing of AB. So bearing is calculated with respect to northing. So this bearing of AB is also calculated with the respect of this northing. So we know angle from here up to here. So to calculate the bearing of AC, the angle comes from north to this line. So from this whole angle, if we subtract this angle alpha, then we can get this angle, yes, that is ultimately the bearing of AC. So bearing of AC equals to bearing of AB minus alpha. Now we will also calculate the bearing of BC, this BC. So what we will do for that, we will use the formula bearing of AB, this bearing of AB plus beta plus minus 180 degree minus 540 degree. So we have the formula bearing of previous line plus clockwise angle between two lines, that is AB and BC, plus minus 180 degree minus 540 degree. From that concept it is written here. And why plus minus 180 degree and minus 540 degree? So if sum of bearing of AB and this beta exceeds 180 degree, then here we have to subtract by 180 degree, and if the sum of bearing of AB and beta does not exceed 180 degree, then we will add 180 degree. And suppose bearing of AB and beta exceeds 540 degree, then we will subtract by 540 degree. And from another method also we can calculate the bearing of this BC. For that we will take back bearing of AB plus beta only. Then how can we calculate the back bearing of AB? So formula for back bearing is 4 bearing plus minus 180 degree. Note that. And here beta is the clockwise angle as shown in the figure direction, clockwise angle formed at B between AB and BC. This AB and BC. Now as we know all these three angles and distance between A and B, but we don't know the distance AC and BC. For that we will use sine law as shown here. So this AC, how can we apply sine law? This AC divided by sine this angle, and this AB divided by sine this gamma equals to this BC divided by sine alpha. Hence the distance between AC and BC can be obtained from this sine law. We will calculate these distances by taking any two of these ratios. So we are now calculated all things, bearings, these internal angles and distances. Now we will find the coordinates of C. Here the coordinate of C is unknown. Yes, for that here these A and B both have northing and easting. Northing and easting, but we don't have the coordinate of C. For that we can calculate the northing and easting of C from these 2 points also. So northing of C equals to, if you calculating from A, then northing of A plus we know the length of this AC, so northing of A plus L AC cos theta AC. Theta AC is here is bearing. And if we are calculating from B, so northing of B plus length of this BC cos theta C. And for easting of A plus length of AC sine bearing of AC. For easting we use sine, and for northing we use cos. And if we are calculating easting of C from B, then easting of B plus length of this BC sine theta BC. Theta BC is here bearing, it means bearing of BC. So in this way we can calculate the coordinate of unknown point from two known points by the method of intersection. Now we will move towards resection. So what is resection here? A method of fixing the position of a point. Fixing the position of point by making angular observations to three fixed points is known as resection. Method of fixing a position of a point. This is the, suppose I am fixing this point, and this makes angular observation to three fixed points. Here three fixed points are this point A, this point B, and this point C, and I am fixing the point this. And this method is known as resection. We have altogether two types of resection. They are 2-point resection and 3-point resection. Here we will discuss only about 3-point resection by Dijkstra method. Another method is Collins method, but here we will only discuss about this 3-point resection and this 3-point resection by Dijkstra method. And for 2-point resection I will make video for this 2-point resection and in another video. So in this video we will only study about this 3-point resection by Dijkstra method and theory portion also only in this video. So let's move. Here the known points are A, B and C as I told, and here unknown point is point O. And let me explain this video. As these point A and B and C are known, so their coordinates are northing of A, easting of A, northing of B, easting of B, northing of C, northing easting of C. And this point O makes an angle gamma between A and B, and alpha between B and C, beta between A and C. Let alpha, beta and gamma are the angles formed at point O when observed between the known points, as I explained earlier. Now we will calculate here bearing of AB, bearing of AC, bearing of AB and bearing of AC. If you calculate the coordinate of point O using this length, then you have to calculate the bearing of these two consecutive lines. But if you calculate the bearing of point O by using this line, then you have to calculate the bearing of this BC and CA. But you calculate coordinate of point O using this line, length of this line, then you have to calculate the bearing of line AB and AC. But here in this case I am calculating the coordinate of point O using this line. So I am calculating here the bearing of AB and BC. So bearing of AB can be calculated as I know the coordinate of all three coordinates, so I can directly use the coordinate for calculating the bearing. So bearing of AB equals to tan inverse easting by northing. Yes, so tan inverse easting of B minus easting of A divided by northing of B by minus northing of A. In the similar way, bearing of AC, in this case I am using this length, so bearing of AB and bearing of AC. So bearing of AC equals tan inverse easting of C minus easting of A divided by easting of northing of C minus northing of A. In this way we can calculate the bearing of these lines AB and AC. Now from Dijkstra method we have the formula like this. This is coefficients. So K1 equals 1 by cot A minus cot alpha. How I have written A and alpha? If you are taking A point, then their corresponding angle is taken here. Similar way, if I am taking this B, then another angle will be angle corresponding to this B. So corresponding to this B is beta. In the similar way for K3, 1 divided by, if I am taking here C, this C, then corresponding to this angle will be here gamma. So gamma, you have to learn this formula for calculating the coordinate of a point by tan extra method. So these coefficients will be used in this formula. Finally, the coordinate of a point O can be calculated by using the following formula. So for calculating the northing and easting of the unknown point, we have this formula. So northing equals to that calculated coefficient K1 into NA plus K2 into NB plus K3 into NC divided by K1 plus K2 plus K3. In the similar manner for easting, K1 into EA plus K2 into EB plus K3 into EC divided by K1 plus K2 plus K3. In this way we can calculate the coordinates of the unknown points. Thank you. If you like this video, please subscribe, and you have any queries, you can email me your problems in this email account, or you can directly comment your problem in the comment box, and follow my channel in civil engineers to enhance your knowledge and build up your career. You will have next lecture on numericals of intersection and resection. I will make another video for the numericals of intersection and resection. And if you have any queries, you can email me your problem. I will try to answer it. If I am not too busy, ask problems from this topic only for this video. For this video, you ask only, not other questions. Or you can also comment your queries on the comment box. If this video proves you useful, then you are kindly requested to subscribe the channel and share this video as much as you can. Thank you.